Good afternoon, everyone. Welcome to this month's member webinar hosted by Wisconsin Cheesemakers Association. I'm Grace Atherton, WCMA's Communications Director, and I'm so glad to have you all with us today as we dive into applications of artificial intelligence technology, or AI, in dairy processing, featuring expert guest speakers from 3 leading suppliers and WCMA member companies in the automation space. First, a couple of housekeeping notes I want to make. Please make sure your mic is muted and your video feed is off to avoid interruptions during our webinar. You can also submit questions anytime during our session in the chat, and we'll do our best to address them all during our Q&A session at the end. Finally, I want to make sure everyone's aware that a recording of this webinar, along with a list of resources and contact information for our presenters, will be shared later this week, so watch for that in your email inbox. And if you missed something during the webinar, don't worry, we will send out the recording. With that, let's take a quick look at our agenda for today. First, we'll hear from Erik Sondergaard of WCMA supplier member Au2mate about ways to utilize your production data to its full potential and optimize your operations. Then we'll turn to Chris Barnes of Calypso, or Rockwell Automation business, for insights on using AI to address process challenges. Next, Cristescu of Tetra will discuss the acceleration of AI in food production. And finally, we'll open the floor for a few pre-submitted and your live questions. So first, I'm pleased to introduce Erik. Erik Sondergaard's diverse background includes agriculture, economics, software development, and sales. He currently serves as sales director for the production IT/OT division at Au2mate, helping dairy and food manufacturers optimize their operations through intelligent automation solutions. Erik, I'll turn it over to you. Take it away.
Thank you very much, Grace, and thank you for all being here. I will share my screen, and I hope you can see it now.
Looks perfect.
Okay, good. Thank you. And my name is Erik Sondergaard, and the thing I will be talking about today is an introduction, the role of AI in the process industry as we see it, and what need and challenge there are to get started with the AI. What we see in typical challenges in the production is that we have a lot of data. We log very many data, but we do not use that many. And one of the problems in the dairy industry is that our capacity and quality can be changed because our raw material is not actually always the same. There is another area about maintenance that we can have unexpected breakdowns. There are some areas in the process where there could be, for example, a filter breach, and we get some bad stuff in our products. So to use AI to monitor our process can be one of the benefits with AI. So this product we have, Intellicy, has 4 main features, and I will come into that later. One of them is that it's very fast with the trend curves, because we have the power from AI. Another area is that we can identify anomalies. You can see it on a little red here. I will come to that as well. But when we are running a process, what AI can do is that it can monitor if something is not what we expect it to be, but still within our set points, it can send out an alarm. It can also be that we want to predict the future. If we are running a process and we want to have the equal products with different raw material, how can we predict the future so we can make modifications that perhaps take half an hour before we can see the effect of our modifications? And the last one is when we are looking into a process and want to find out the correlation between different parameters, then we can use the analyze tools as well. So what we are talking about when we have AI, we are talking about running a model. And in this example here, we have 2 filters, and we have the permeate flow out here. And in this case, a customer wants to see, okay, if we will have a small breach in one of these filters, then we want an alarm. So we will measure some of the equipment right here. And IntelliSea is a no-code platform, so it's very easy to make the models. So I want to try here to say how fast it is, so you can see how fast it is. So in IntelliSea, looks like this. We have a menu on the left side. It's almost always with this type of software. And I want to create a model. And the way I want to create the model is that I want to make this anomaly. I go through this wizard and say, okay, what do I want to measure? I want to measure the flow sensor on the one side, and I get immediately a trend curve, and you can see how fast the system is if you are zooming in, zooming out. And then I say, okay, what could have an impact? And then I will put in all the parameters that could have an impact on a filter breach. And I put that in here. I add the equipment and click next. I give it name, just like creating a Word document. And we now have the model. And I will then say, okay, let's train the model. And it will be training in around 20 minutes. And now I can see there are 2 lines up here, a yellow one and a blue. And it's with the 2 filters that you are looking on. And if I go back in the history data, I can see there is some red lines here. And if I pause the movie here, you can see that these 2 lines should be very equal, but here there is a difference. And I can see the difference down here as well. And then it tells me there is a small breach in the filter. So for this customer, they didn't have to take a test. They knew it and could stop immediately. So this is one of the areas. Another area is when we are making the analyze, that how can we optimize our capacity and maintain the quality. And there we use the analyze tool. If you see all these lines is batches. There was, at this process, the operators were talking about, we got different outputs, but they have, in this case, actually 35 parameters they could change on. So they took all their production for 1 year in this tool, and each line is a production. So if you look on the left side, this is the capacity. So they talk about that they have a different output, and yes, they have. The yellow one is the good one with 85% and more, but you can see here they have a lot that is not so high in performance. And we have a quality near scanner over here. So you said, okay, we want to have the right quality and we want to run on high speed. What should our parameters be like? And then we can just like in Excel, set a filter up here. I can drag up and down here. And then I can see, okay, now we can look on a pattern. How should the production be? So I selected 85% and I have selected high quality. And in this case, we can see that the speed motor that fills in the beginning of the system has been running at too high speed, and then you will queue the system. So only when it's between this area, if I go down here, in this area, we have the best results for quality and performance. And actually they found out of all the 35 parameters, it was only those 3 parameters that has if they are within this range, everything went well. And in this case, they increased the capacity with 20%, and they only took 1 day because when they got this tool, they could see it. If we want to dive a little deeper in it, we have a model called ProOptima, and that's where you could define good and bad yield based. So when you, for example, make cheese, you said, okay, the dry matter in the cheese is best when it's low and not too high. So you can define that with parameters, and then it can show, okay, how was your every cheese actually measured. So in this case, they took an image of all cheeses and say, okay, this has too much dry matter. We want to move over here. What is the reason? And then the tool can say, okay, reason one, reason two. Reason one has 20% influence. Reason two has 15%. And then in this case, they were not talking about all the ones down here, some are 37, but they could say, okay, reason one is the most important one. And then they used 6 months to optimize. And after the 6 months, they now use 1% less milk for the same number, the same amount of cheese with this tool. Of course, it's not easy because then they have already done it before, but now they have like a GPS. This is what we should be working on. And another use case is from Tine, big dairy, the biggest dairy in Norway. They have production of protein powder in the spray tower. And again, if you look on all the dots, it is the protein powder for each patch. And you can see it, they are all over the graph here. But something happens here, and now you have them very close to here and very close to here. And it's because they are producing two products. And the way they could make more equal product was again AI, because when they are running the process and the protein go up and down, they used AI to predict the future. So the yellow one is the future, so it will always be ahead. And then the operator knows that he should not make so big justifications. So on the right side of the line, it's more flat, and then they can go closer to the set points. And for the operator, this is when I analyze it, but for the operator that are running on the SCADA system, they have put in an AI button, and then it will show them the historical data and the future data. So that's how it is used. And the next 2 slides is more for sending it out. Grace will send it out, but there is the typical issues that people have when we are talking to them and they are interested in AI. I'm almost running out of time, so I will go a little faster through these. And this is just how it works. So how, if you are interested in say, okay, could that be something for us? Well, on your customer sides, we will read your data, and then it will go to the cloud where we have the big engines. And then we have 2 outputs. The one is the IntelliSea front end, which you have seen now with the graphs and all that. And we can also put integration into your existing systems. So we can help optimize production, talk about quality, and make it data-driven decisions. And if some of you are thinking about what about the money? Well, when we are looking on the typical use cases, that is that if you give us $1, you will get $3 to $10 back within 1 year. So it is a good investment. I think that was all from me. If you would like, take a photo of the QR code and be connected. I will write things on LinkedIn about AI and get more stuff. But thank you. I think it was the time, Grace. It's okay.
Yes, that's wonderful. Thank you so much, Erik. That was fascinating. Really interesting to see how all of the data comes together on that platform and what it all looks like. Next up, I'm going to introduce our second speaker. Next on our lineup is Chris Barnes of Calypso, a Rockwell Automation business. Chris is a leader in data and AI consulting for Rockwell Automation, bringing experience in manufacturing operations, digital strategy, and industrial AI implementations. Chris has guided numerous companies in the CPG industry in leveraging AI to enhance their productivity, quality control, and operational efficiency. So Chris, I'll turn it over to you.
Thanks, Chris. Could you just confirm you can see my page? Yes.
Yes, looks great.
Fantastic. Also, Eric, thank you so much for that, like really enlightening conversation and some approaches on really data-driven uses of AI technologies that look, quite modern. I am going to preview here or provide a preview of a talk that I'm going to give, I think on February 26th. So coming up here pretty quickly, that's going to go into further detail on each of these buckets and really talk about the trends that we see across CPG industry broadly and their use of AI solutions. And you'll notice a number of these, which were highlighted in Eric's final page there in terms of applications of AI. I want to anchor around two real focused use case areas in the domains of automation and control, and talk about the kind of relative maturity of some of the solutions that are out there that can be adopted in dairy production, dairy processing industry. And fun fact, I don't know if everybody knows this, but the dairy industry has been broadly using AI since last century. So in the early 90s, the use of AI within the model predictive control field was being adopted, really born out of that domain. And I'm going to highlight some of the uses of AI within MPC or model predictive control and highlight a specific case study of high impact there. Then I'm going to talk about one of the more nascent areas, explicitly utilizing machine learning to learn some of the controls approaches, which we may not be able to determine explicitly from controls theory. And then I want to provide you a preview into the future. So a new area of investment and research and development in the form of automation co-pilots. So think ChatGPT at the edge, at the HMI, to help navigate root cause analysis and really accelerate the troubleshooting time from the order of hours to minutes. Okay, so first, I want to anchor around the outcome. So think about driving improved quality with the use of AI in the form of model prediction, in the form of model predictive control. And so when you hear MPC, think about processing like standardization, which is a complex component balance or mass balance of, oftentimes you might have 20 individual, PID control loops, which in a traditional control strategy, you're operating independently. And there are scenarios based on operating conditions where, two individual control loops might be competing with each other. So think about one controller determining that I need to increase or decrease, fat content, but then that having an effect on protein content within the standardization process, and that triggers action on a second control loop, and we find these things competing with each other. So the particular area of focus for MPC and the use of AI here is in these kind of complex systems, multiple control loops, and in particular in this case, when these individual loops are competing with each other, you find high variability in finished good quality on a kind of analytical scale, percent of proteins, moisture, fat, et cetera, contents. And what that leads to is giveaway and yield loss. So this is a real world case study in dry powder dairy production process around standardization. And what's listed out here is the overall control strategy and considered manipulated variables marked as MDs, the disturbance variables, the DVs, which are the things that I can't directly measure, but I need a control system in order to account for the inherent variability that I'm going to see in raw milk composition, cream composition, et cetera. And then our CVs are the controlled variables, or in other words, the things that I'm trying to control for. And in particular, I care about trying to optimize and drive minimal variation in things like powder, percentage of fat and percentage of protein in my finished goods. And down the right-hand side, I want to key in on the results, right? So the upper graphic, what this is looking at is the kind of wider bell curve that you see is the prior case, and then the taller, narrower bell curve is the after case, after implementing this technology and having AI learn and control a multitude of different individual PID loops using MPC. What we see here is if I can tighten that band of variability in finished good quality, then that allows me to really shift the target set point lower toward the acceptable operating limits. And all of the delta that I'm able to shift that kind of center line results in improved yield, improved production rate, more energy efficient operations, and ultimately driving real significant production uplift in terms of dollars returned back to the bottom line. And so that's what's being shown in the upper right quadrant. Just below that is actually on an extended run, just to illustrate what we're trying to accomplish, which is maintaining the kind of yellow bar, which you can barely see, which is perfect, is the actual measurements in line relative to the target, which is represented by the green line. So, as I mentioned, this is a mature capability. As we look toward the future, there's also some interesting developments that are happening in the MPC space, including things like adaptive loop tuning. So, MPC performance is always dependent on the performance and accuracy of individual loops, control loops that feed into the overall model. There's investigation and development in the space of having AI constantly monitoring the health of individual control loops, tuning their gain parameters, and ensuring that the ultimate model that the MPC control strategy is running is most effective and accurate. There's also some usage of what's called soft sensing, so utilizing AI to impute measured or parameters or process conditions which are immeasurable directly. So really the takeaway is mature use of AI. This industry has been utilizing this for over 30 years since last century, but there's also still advancements being made to continue to push the needle forward and drive further benefits within this domain. Next, I want to highlight something probably more modern, but still mature from the standpoint that there's live capabilities out there in real world production that is focused in this domain that we call perfect fill. And so now we're, again, thinking about outcomes or the end in mind. We're thinking about capacity gains. So in this particular process that's running, it happens to be on a mayonnaise filling line, or there's a multitude of different applications out there. But think about medium to high speed filling, especially with viscous materials. There are control strategies which are not easily defined explicitly. In other words, from controls theory, it's not always clear what the relationship is between measured viscosity and densities of the ingredients and the parameters that should be executed on the fill heads in order to get the perfect fill every time. And what we always run into, right, is we have got a strict lower limit below which will cause complaints or quality holds and significantly hit into the bottom line, whereas inaccuracies in the fill level that are too high result in product giveaway. Often what happens as well in some of these applications, you have frequent operator adjustments who are monitoring, taking inline measurement points, and then trying to make human decision making to make adjustments, trying to keep things in control. It's actually a similar concept as MPC, but the difference is the technological approach. So rather than building a model and controlling a multitude of PID loops, I'm now thinking about using self-learning AI to go derive a control strategy, which I may not be able to develop explicitly from controls theory. So what, similar to the prior case, what I'm focused on now, just in this upper right kind of quadrant, similar level of variability in the prior case with the wider bell curve, which I then try to tighten the variability, and that allows me to run my equipment closer to the most optimal set point of the lower limit on the fill, and all of the delta from the prior case center line to the future case center line translates into direct benefits. And so the second graphic on the right-hand side in the middle is, a real-world production run where what I'm looking at, I don't remember the number of heads on this particular filling equipment, but let's just call it a dozen. So I see, each line individually representing the performance of an individual fill head on this equipment. And the kind of blue line that's fairly faint, but in the middle where I start to see separation of all of the lines on the right-hand side of the page is where I turn on the perfect fill engine for only a subset of the overall fill heads. And now what I start to see is a subset with greater variability, another subset that is more tightly controlled at the target. And again, that delta or that separation is what translates into a reduction in giveaway, elimination of underfill, and it's important in these applications to be able to do them at pretty high speed. So takeaway here is beyond the use of kind of the old hat known technologies where we're advancing with adoption of AI in fields like MPC, there are more data-driven workflows, self-learning algorithms that directly are being built and applied to common use case applications across food and beverage like perfect fill. The final thing, and I'm just going to let 2 videos play and not go into extensive detail on this because now we're looking into the future. I'm providing some previews of some of the R&D initiatives where we are investigating building co-pilots directly into a number of different applications. So on the left-hand side is a tool called Design Studio Copilot, which allows you a natural language interface to characterize a portion of code that you want to write and then have it generated directly by a copilot, just like ChatGPT or an equivalent would do for you. But on the back end, it's fundamentally a text-based coding language, but then it translates that into the ladder logic as we're all used to. And then on the right-hand side, what is running is a more frontline worker HMI level engine, which is investigating or monitoring for anomalies that are detected on equipment, and then translating those anomalies into the most likely issues or root causes of potential failures, and then pointing the user directly to the documentation such that I can try to accelerate that root cause resolution time and bringing equipment back online. So again, now this is more the look into the future of what's to come and a lot of innovation in this space. I think the last thing to say is people always ask, this is great. You just showed me 3 uses of AI. You also showed me, 5 other potential areas that I can consider. How do I get started and how do I know what to go after? And we counsel our clients in thinking about the opportunity and value analysis, get to a high-graded set of use cases that are right sized for your operations and business. Think about the scalable and maintainable architecture in order to go execute against that, and then really be systematic and thoughtful about your implementation roadmap as you go after executing against your AI strategy.
All right, that was great, Chris. Thank you so much for that presentation. Super interesting, again, to see all that data at work and get a little bit of a glimpse into the future at what might be coming next. It's very exciting stuff. So next up, I'm excited to introduce our final presenter today, Cristescu. Crystal is a seasoned sales enablement leader at Tetra Pak, specializing in automation and digital solutions for the dairy industry. With expertise in leveraging cutting-edge AI technologies, Crystal helps empower owners, managers, and operators to enhance their operations, streamline workflows, and unlock the potential of digital transformation. Crystal, the floor is yours.
Thank you. I am excited to be here and very nice to be following up from both Erik and Chris. Sounds like we're going to be discussing similar kind of trends and things that are in artificial intelligence. And for me, I wanted to focus on some of those, also include some case studies as well. I am a sales enablement leader at Tetra Pak. So just a little bit about Tetra Pak. We are a world-leading food processing and packaging solutions company. So we work closely with customers and suppliers and across 160 countries in these various applications. So some of the trends that are going on and why do we have this topic? There's discussions around lowering that total cost of ownership, increasing sustainability, looking at securing food and safety and that quality effect, digitalizing around that skilled labor force, and of course, the legacy equipment and moving to more modern standards. So what is the need for having smart factories to help address those? Of course, there's secure integration, so making it more seamless for those, that total cost for engineering and that startup, that optimization that we continue to look at with different operators around quality and lowering cost, and just always even having a secure connection and looking at different data points and values. So then those future discussions and decisions could be made. And so just looking at the, I want to make sure everybody can see my full screen, correct? Okay, great.
Yes.
So yeah, so some of the main things to discuss is looking at automation that usually to implement automation across the end-to-end, you'll see an increase around that overall equipment efficiency from 7 to 20%. And as far as the capital spend in that future, 25% of that is going to be accounted around automation and digitalization in those solutions. So when we think about the Industrial Revolution and kind of looking at, from 4.0 and now talking about AI, in that 5.0 stage, there's some ways to look at all parts. So looking at automating at the equipment level and providing those standards and optimizing that cost. And then at the complete factory level, end-to-end solutions and orchestrating some of that data across the factory. And then at a business or enterprise level, or even multiple factories, and using those insights and that data to understand and create different solutions and cost optimizations, and that excellence in general. And so just looking at baselining again with automating at that factory floor level, there's 10 ways or opportunities: increasing uptime, reducing that human error, saving on materials, standardization, traceability. And in order to do some of that and looking at optimizing that continuously, right? So making it repeatable, as was discussed, the variability, and then creating that reliable data source, and then understanding what that data means. And so just understanding how the data orchestrates kind of from end to end. So you'll get data points from milk reception all the way through that shipping areas. And so we may be looking at time, transactions, and different events, and all those data collection points. And how could we then better understand and prepare that data, be able to conceptualize it, and then be able to create analytics model and that visualization. And then finally, with all that data, then you're able to make those, see those insights at that high business level, and then create those decisions for quality and a number of resource improvements like asset, energy, and material management. And then at that high level discussion, we're going to be including a number of teams and being able to hit different KPIs across the board, whether it's with the business experts or looking at some of the inputs and the data that may be looked at on the data side through the data scientist and the OT and IT engineering. So just quickly, I'm just going to highlight 5 and then go into 3 in detail. But we have at Tetra Pak used to develop a number of optimization across cheese and powder, ice cream, the clean in place procedure, the milk segregation, and then a virtual assistant and issue resolution. And so the first example I'll go into is around cheese and the variables in that cheese production process, specifically just looking at, you know, from the silo to the final cheese, looking at the vat, where a number of data points can be collected throughout that process, but just looking at the transfer pH, the time in the vat, you know, the cut times and speeds, and the temperature, et cetera. So the challenge was that we were asked to help achieve superior moisture levels, decrease that pH, improve the overall quality, and increase the yield. And so with that solution was something that was going to be more scalable across multiple factories, and being able to validate it through clinical trials and then make it seamless through different parts of the process without much disruption and cost there, and then tailor that solution based on those unique production needs. And so the outcome was a reduction of moisture variability, an increase of average moisture, and then that reduction of pH. And that yielded a between 1.7 and 2 million yield per year per factory. And that was looking around a capacity of 10,000 pounds of cheese per hour. The second one I'll talk about is the cleaning in place optimization. This particular example was around the high protein drinks. And the pictures on the left showcase through our aseptic ultra high temperature process. This was the buildup and the fouling that was formulated. And so the challenge was there was a number of production halts due to those cleanings, and then of course a risk of contamination. And so we used AI-driven recommendations based on the algorithm that was analyzed using different data points to predict that optimal timing for when the CIP needed to take place. So it reduced downtime and improved sustainability. So that led to an increase in production time. It extended the machine runtime between a half an hour and 2 hours per cycle, which also helped reduce the contamination risk, making sure it was cleaned when necessary. And that led to a $1.3 million revenue increase per year per factory. And that was utilizing clean in place on 3 machines. And the last one I will go over is the artificial intelligence and milk reception. So just looking at when the milk is delivered, and that raw milk, it comes from a number of suppliers, sometimes a number of farms, and just looking at those producers and that composition of the milk in different times of the year and such, then there might be different variations of that protein and fat. And so utilizing some of the lab data that's utilized, and having some analysis to understand and know where we could then take that milk and best use it, whether, for instance, could be in a specific mozzarella or cheddar cheese, you know, using different suppliers or the UHT way, what have you. So, so this particular case, the challenge was that there was lack of data. It was hard to have predictive and even forecasting on some of that that plan. And it was difficulty to even be able to even analyze the data itself. And so the solution was able to collect that data, process it, create a cluster of information using the algorithm, and then realize what would be the best destination for the raw milk based on those parameters and the need. And overall, that created a increase in the yield of $1 million in the US dollars, rather, in a dairy we had in Southern America. So just to wrap it up and just to cover, it looks like we're all headed this way with cobots, robots, and automated guided vehicles, you know, and enhancing the foundation, just the processing and the packaging, utilizing automation as a foundation, we are looking to seeing those increases in that throughput, the quality, being able to have it repeatable, and obviously having a savings and reducing risk. So thank you guys for having me today, and I appreciate the opportunity to share this information.
Thank you so much, Crystal. Very interesting information and really impactful to see all of the different applications and the ways that those technologies can create real and significant improvements and gains. Next up, we'll turn to our Q&A session. So to start, I want to remind everyone that you can feel free to share questions in the chat at this time, and we will do our best to address them all during this Q&A. We do have 2 pre-submitted questions that we'll go over from our attendees, but always welcome to share any additional questions you have in the chat as well. First up, this is an interesting one. How do you see AI's application distinct to dairy processors versus other agricultural industries or industries in different verticals? Would anyone like to take a first crack at this question? I assume you all have experience in different areas besides just dairy. So it'd be interesting to hear your insights on this.
I can get us started on this, and I'll actually come at it from the angle of how similar the problem statements and the data sets and the problems with data are across industries. The other observation that I'll try to seed here is the learnings that we could pull from other industries about the best ways to approach the data collection, contextualization, aggregation, et cetera, process to set up for success on your ability to deliver against AI solutions. What I see, and by the way, I do work across, I don't know, mining, oil and gas, automotive, med tech, pharmaceuticals, in a variety of different forms of CPG and food and beverage. So some of the learnings that we can pull from, let's say, oil and gas is very robust technologies for collecting and historizing time series data, process data, anything out of a controller in very efficient ways to make that available to feed into AI models. Aerospace is an area where, which is as well as medtech, are areas of advancements in terms of cybersecurity. And so when you think about standing up the network infrastructure for creating the data and making it available for AI, the ways to do that in a secure and sustainable and maintainable fashion, we looked at some of those areas for lessons learned. So really, I think the steering or the guidance on this question is actually to look for some of what other industries do really well, to focus on how you can get your data in a state to make it accessible to your data scientists, your citizen engineers, to be able to make maximal use of this rich data set that you have coming out of connected equipment. And then what you find is that there is a ton of similarities between the types of problem statements around optimization, predictive maintenance, quality control, computer vision applications, et cetera, that you actually see as similarities across agricultural and in other industries.
That's a great point. Very interesting too to consider the connections between industries that we in the dairy processing world might not think of, like aerospace. I wouldn't normally make the connection in the front of my mind between cheese and dairy processing and aerospace engineering, but the comparison is there, and it's true that there are lessons to be learned, I think, in all of these areas. I want to kind of branch off of this question a little bit because Erik, knowing that Au2mate is based in Denmark and that you serve clients, both in Europe and presumably here in the US as well, and many WCMA members are US based.
Yes.
What are the differences you see here in AI applications between the dairy processing industry overseas and the dairy processing industry here in the US, if there are differences?
There are some differences. what we see is, for example, what type of equipment you are running the data on, that we need all AI, you need the data. As Chris said, that it's all about data. So when I see a dairy, somebody sees that it's create milk, I see it create data. So you can make the milk better. So there are, in the way on how long you are in the automation, there are some differences from what we see. We are in US, we are in Australia, we are in the Middle East, and we are in Europe. So we are aware of how to work on all markets. And like you said, Chris, where do we see the AI in? We also see it in the oil and the mining industry, and it's typical where you have a lot of products you produce and where you have quality issues. So it's typical where AI is a good place to put it in.
Mm-hmm. And Crystal, knowing Tetra Pak is also obviously a global business and operates in a multitude of different industries. Anything else to add?
Yes, no, I was going to lead that way with the conversation. We are specifically focused on food and beverage, but yes, like you mentioned, across the globe, we see that some like advancements, even let's say in China, that there may be one of the first end-to-end smart factory solutions. And so just that implementation and then that learning. So we've done a number of pilots and being able to, kind of understand how to become efficient. What are other points that, and the limitations maybe that some industries might have, even with their just like natural resources on the energy side. And so, yeah, we've, as a company, what I enjoy is that a lot of times those solutions will then come and become while it was local, it becomes a global solution once they're able to pilot it and kind of see it through. So that's the advantage in that case.
All right. We'll move on to our second question here. How will AI change the business processes at a manufacturing plant? I think this is a great question for folks who might be working for a company that is just getting into implementing AI in their plant more widely, and maybe, if you work on the production floor and you're not as familiar with these technologies, it's easy to see how this kind of development and what's coming in the future could raise questions for you about what does this mean for how we do business every day. It's looked a certain way, for a while, and now things are obviously rapidly changing and will continue to change. So how do you see AI changing those specific business processes, those day-to-day things at a manufacturing plant?
I'd love to respond first on this one and comment on what's like probably my favorite business process that I've seen affected through the implementation of AI. And that is, think about anywhere online where you have people standing and doing inline quality checks for whatever's coming down the packaging line. If we target those areas, and there's numerous applications of, for instance, putting in inline camera systems to be able to check the labels and check the placement of caps. So check all of the kind of inline QC checks that need to be done on a packaging line. Or think about utilizing AI as a soft sensor to try to approximate measurements on the actual formulated good as it's coming through the production processes, and trying to take the burden off people from having to perform those manual QC checks, and then writing that number down or putting it into a system where they sign their name next to it, and then goes into a filing cabinet that's there for an auditor to come look at 3 years down the road and have potential liability if something's entered in incorrectly. Think about the actual burden removed from some of those frontline operators by having inline uses of artificial intelligence to perform some of those tasks. We often see working with our clients that when you start layering in some of those beneficial impacts to remove the burden around the repetitive, sometimes even higher risk type QC checks, these are the real benefits, and that's why I wanted to kind of jump in and talk about the benefits and the positive impacts that we see from kind of the human standpoint of inline operators with once you're able to equip them effectively with the data and the AI technologies to offload some of those repetitive tasks.
Crystal, you unmuted. Do you have something you want to add here too?
Yeah, sure. Being in the cheese industry, probably all of us has walked that floor and saw something starting up and noticed all the paper, maybe all the lab, the checks and the data points. And so definitely just moving more away from, having that paper to something digital and that collection. And again, kind of as Chris was speaking to around the operators, maybe not as much of a need for as many operators, or even the quality of, let's say, even a checklist, saying, okay, now that this process has moved from one stage to the next, in order for it to move, check these 3 things, right? So, maybe making, the job of the operator easier, or maybe even maybe harder. But yeah, there's a number of ways that it would impact kind of that process in general.
And that's a huge one, Crystal. Appreciate you commenting that. Like, think about startup procedures on a dryer that requires you to shut down and clean in place on some cadence. So and you always are battling kind of those transient startup conditions as you try to get to steady state, and applications of deep reinforcement learning in those kind of transient zones to try to go as quick as possible in your startup procedures. Yeah, another huge area. It's all about unloading some of the burden from those repetitive tasks that are hard and take a lot of focus from operators to perform.
Yes, and from
would you like to jump in here as well? Yeah.
Yes, from my point of view, I used to say that it's like to have a GPS in the car. If you're driving from one place to another and you know the roads, you typically in Europe start the GPS, and I ask why. Because you know how to find out. But yes, but if something happens, it could rearrange my trip, so I will still be on the right place on the right time, so I could leave later than before I have a GPS. So AI can help the operators to have like a GPS, and even further, if you have some, you can put in closed loop, and then it can run automatically, or you can have one operator to look after 3 processes, and together with, for example, FOSS inline or online instruments, where we can put in more sensors, we can make products more efficiently. So take care of the environment, for example. So I see that all the lab area would change if we could measure with AI and go closer to our set points. So that could be an area.
I like that GPS analogy. That's helpful for folks like me who are not in this space every day to visualize how that could be useful. And I appreciate too that all of you mentioned making these tasks faster or easier or more efficient for the operators. It's not just all about automating the entire process so that you don't have to have a person there at all. Sometimes the solution and the win is really that you might be able to make a part of your production a little bit easier on the people that you hire, that you put on that task originally. And that's, I think it can be reassuring for some of us who are maybe a little bit more hesitant about AI and automation and how that world is going to look in the future, to hear, yeah, there's absolutely still a place for, for your dairy processing workforce. It just looks a little bit different than it used to. I think we are done with our preset questions. So real quickly, I'd like to go ahead and make one last promotion for our next upcoming WCMA webinar. That is going to be focused on setting and reporting greenhouse gas goals. So please feel free to join us for that March 20th. Registration is open right now at wischeesemakers.org. So you can find all the information on that online. Thank you again to all 3 of our presenters. You all were fantastic sources of information. We appreciate your time and your efforts. And just a reminder to all of our attendees as well that we will send out a link to a recording of this webinar along with some resources and helpful contact information afterwards. So please watch for that in your email inbox. Thank you again all for joining us today, and we will see you on our next webinar. Have a good afternoon.